Welcome to Learning Beyond Limits, where learning has no end. Today we're going to talk about ratios, ratio and proportion to be exact. Ratio and proportion can be a very challenging topic in mathematics, and that is why we're going to talk about it today. But first, we're going to break it down into small pieces. We're going to talk about ratios first. What is a ratio? A ratio is a comparison of two quantities. So I could be comparing boys and girls. So let's say I have two boys and over here I have three girls, and I'm making this comparison using ratio. So I can say I have in this class a ratio of boys to girls, and I can represent this ratio in different forms. I can represent it as 2 and a colon 2 to 3, and I could very well just put B here so we know this column is boys, and G here so we know that column is girls. And there's another way we can represent it. We can talk about 2 and the word 2, 3, and also we can write it all in word. And also we can sometimes represent ratio as a fraction. Note I said sometimes because not always can ratios be represented as a fraction. In fact, this particular ratio cannot be written, or rather cannot be represented as a fraction, because if we have 2 over 3, we're saying we have 2 boys out of 3, which is not practical. However, we can represent the ratio of the entire class. We have 5 students in the class, and we can talk about 2 boys out of the class of 5. This is okay, this is not okay. So the question is then, when do we represent a ratio as a fraction and when can't we? The answer is simple. When we're talking about part-to-part ratio, we cannot represent it as a fraction, but when we're talking about part to whole, we can represent it as a fraction. Well, another example, let's say we're representing this fraction here, the circle that we have just drawn, not necessarily drawn with any instruments, so it's looking a little bit wonky, but if we're representing this circle, then we could represent the shaded portion, and let's use S for shaded and US for unshaded, and so we could say 1 for the shaded, and we have 3 unshaded, so we can say shaded to unshaded. However, note that the shaded is a part and the unshaded is also a part, so we cannot represent the shaded to unshaded as 1 over 3. We cannot do that. But we can represent the fraction, the whole, and we can say 3 out of 4, which would represent 3 referring to the unshaded and 4 representing the whole. We could very well do that. So what is the purpose of ratio and when can we use it? That's a good question. Ratio can be used to represent or to present statistic models to a population. So let's say doctors were talking about number of people tested for the novel coronavirus. Well, doctors could very well say that out of every 15 people tested, 4 people will have the virus. And so we could say, well, tested positive and tested. So therefore, we can see the ratio of 4 to 15, and so we can say of every 15 tested, 4 has the virus. And this is a very effective way of communicating to the public an idea of the spread of a coronavirus or coronavirus. And that would be a very easier way to do it as against using statistical models. So the purpose of this video was to get us to understand the importance of ratio and how we use it when we use it. Remember, this is Learning Beyond Limits, where learning has no limit. Don't forget to click the button like and subscribe. Leave me a comment, and of course, if there is any